here is my setup for mini project number 3. I'll start by going through the requirement A with the ultrasound sensor and the servo motor. Sorry, that's Tyler's over there going off, but my tape I'm starting is treating 20 as 0 just because the start's cut off, so I'll put that measurement there by showing there. That's 20. Okay, so here's my code for A1. I'll upload it on. Scroll the code, there it is. It's uploaded, open my serial monitor, and it prints US lookup table. So now I'll move the box 1 centimeter out, press my button. It takes 10 samples of the time in microseconds, and then it calculates the mean and the standard deviation for each. I also have a program that it will say inch mark 1, and then I can keep moving it to the second inch. Hit the button, takes another 10 samples, calculates the standard deviation and the mean, and it says inch mark 2. You could move it to anywhere and it would take the 10 samples, but I have it in order, so it will go through all of them. And then once you have all 30 inches done, I went and I created a lookup table on Excel with the inches and the means, and then from this I graphed it and then put a linear trend line on, and I used the equation of the trend line to calculate the conversion from your time to inches to the distance in inches, and that was used for in a part A2 to fill that requirement. So we can go over to A2, and here's the code for A2. Upload it. And open the serial monitor. So A2 will run automatically. It runs every second. So I can now, I can move the box to the desired distance. So we can start with, if you want to come out here, 10 inches from the point. It shows 20 degrees. And the servo motor shows 20 degrees on here. And it also will outprint that. So I'll stop auto scrolling so you can actually see it. But it takes 5 samples, then prints your mean, standard deviation, the distance in inches, and your angle. So your angle in here is 20.5. It's going to show 20. So now I can turn back on auto scroll, and I'll keep showing them, and I can move. Just as I move it in closer, you can see the angle changes. I can take it further out. And the angle on the will also change on the LED display, and it can go all the way out to 30 inches away. So you can see there 50, which is 30 more than 20. And it will show, oh, sorry, my numbers are kind of upside down, so they're hard to see, but it's bouncing around 56, 57, around there for distance. So it's a little off when you get too far out, but it still stays fairly close. Oh, there we go. Yeah, so 60 there. And that's how this one works. And then keep moving it. So it's only updating every second. I could make it go and update faster by changing the delay, but I just did this so that you'd actually be able to read the serial monitor. And then that fulfills requirement A. And then I can go on requirement B. So to do requirement B, I can upload my code. So upload my code. And then I just rotate this because we are now working with the infrared sensor. And we will treat 50 centimeters as our 0 point for this one. And I just want to set my wheel up to get this leveled. So it's pretty well level. So I'll set the box on 50. It's touching the sensor. Good. So for this one, code is uploaded. I'll open the serial monitor. It says press button to start IR data collection. You press the button. Oh, that was at 0. That was my bad. I shouldn't have pressed the button yet. I should have moved it first, so I'll just re-upload it. So yeah, start. I'll go 5 centimeters out because we're trying to go 5 to 25 centimeters. So it's 5. Press my button. It takes 20 samples. And these are originally taken as 10 bits. They're converted to 8 bits before they're printed in the serial monitor by dividing by 4. And then it takes the mean and the standard deviation. And then that's all for your first one. And you can just keep moving it out and back in a centimeter. Press the button again. And then you can see it starts generating 20 more samples. And then prints your mean and standard deviation. So like the other one, I went through these all the way up to 25 centimeters away, and I developed a lookup table using means. So here it was. We did our centimeters and the mean value, an 8-bit, that was my output at that value. And then I graphed this and put a trend line on it. I did the polynomial trend line and took the equation of that trend line and used it to create a conversion calculation for B2. So in B2, just make sure that, okay. So in B2, I can upload this one on. I'll show the serial monitor. This one also, like the other one, goes every, here, pull that away. Every second, it'll output values. So as you can see, it does display on the LED the distance away. So if we're treating, as I said, we're treating 50 as 0. So 60 would be 10. So you can see here, it's fairly accurate, somewhat close. It's a little off, it's hard to see though. But you can see here it's printing out. I'll put off auto scroll. It prints out your 20 samples, and then it also prints your mean, standard deviation, distance, speed. X2 is our distance. And then as you move farther away, the motor speed slows down and it still displays your distance away from it. I'll put auto scroll back on so you can see. And it's still printing all those values. So, see there, it's displaying 25 there, bouncing a little bit there, but it's still displaying everything. And it changes the speed of the motor as it does this, as you change it, your distance away. When it gets closer, it runs faster. And that is how the whole system works. And for A1, the values also print off to 2 decimal places for the mean and standard deviation. And here is all my standard deviations now that they're in my lookup table. Just an edit from B1 code. It is printing with only 1 decimal place on them. And before I didn't include my standard deviations in my lookup table, but they are there. And I do have them, they are being printed as I go along.